Today's learning target is students will be able to evaluate product of powers and powers of powers. As you can see here, a to the n times a to the m is equal to a to the n plus m. It's important that these are the same base. So it's both a, so therefore we add the exponents. An example using real numbers is 2 to the second times 2 to the third. So they both have the same base. You can see that here. They both have 2 as a base. So we add the exponents. If we look at that number, it's 2 to the second. So therefore, we have 2 times 2 times 2 to the third. So 2 times 2 times 2, 3 2's there, is then equal to 1, 2, 3, 4, 5. 2 to the fifth. Let's try another problem. Here, we have 2 to the fourth multiplied by 2 to the fifth. So that means, since they both have the same base, we add the exponents. So we get an answer of 2 to the 4 plus 5, which is then equal to 2 to the ninth. When we do this problem, there's no way for us to use our new method. So we must go 3 to the third is 27 times 4 to the second times 16. So we can't use our new method because we don't have the same base. In this next problem, we have the same base of negative 5. But there's no exponent on negative 5 that we can see. So we know that there's a little invisible 1 that's always there, because any number to the 1 exponent is simply that number. So now we have negative 5 times negative 5 to the 6th. That simply means that we add the exponents and get negative 5 to the 7th. Our next problem, we have x to the third times x to the 7th. So remember, our bases match, so we simply add the exponents. So what we get is x to the 3 plus 7, because when we have exponents that have the same base, we add exponents. So we get an answer of x to the 10th. The next problem we're going to do is 6 squared times 6 to the 4th. That's simply 6 to the 2 plus 4, which is then equal to 6 to the 6th. The next problem involves fractions, but don't let that scare you. We simply have a negative 1/2 to the third times a negative 1/2 to the 6th. Notice they're both negative 1/2. It's important that they're both negative, or they wouldn't be the same number. So here, we have negative 1/2 times negative 1/2 to the. So we simply go negative 1/2 to the 3 plus 6, which is then equal to a negative 1/2 to the 9th. So here we have z times z to the 12th. Take a minute, think what exponent would a regular z have? The answer is just 1. Because z to the 1 is going to equal z, and z is equal to z to the 1. So z to the 1 times z to the 12th is simply z to the 13th. So the next problem we have here is 6 squared times 6 to the 4th. So since they have the same base, we add the exponents. So 6 to the 2nd times 6 to the 4th is going to be 6 to the 6th. So the next problem we're going to do is 6 to the 2nd times 6 to the 7th. So since they have the same base, we add the exponents. So we get a 6 to the 9th. You may be getting the hang of it, but don't let problems like this kind of trip you up. So right now we have a negative 2 times negative 2 to the 3rd. So when we add our exponent, negative 2 would have just a 1 for an exponent. But it's important that the parenthesis goes on the outside of that negative sign. If it didn't, we just have a positive 2. And since we're trying to multiply exponents here, or when we're trying to multiply numbers, we want to add the exponents. So we have a negative 2 to the 1st times a negative 2 to the 3rd. So our answer is going to be negative 2 to the 4th. Our next problem we're going to do is x squared times x to the 5th. So with that, we have x as the same base, so we simply add the exponents and get x to the 7th. What I want you to do now is work on these 4 problems. Write them on your paper. Now, I really don't want you to get tripped up by this one. It's a little tricky, but don't be fooled. Next thing we're going to talk about is powers of powers. Powers of powers simply means we have a number with an exponent, and then we take the exponent of that number. So a to the m, all quantity to the n. So we have a to the m times. So we're going to multiply our exponents here. A to the m times n. Let's look at an example. Let's look at an example. So here we have 2 to the 2nd to the 5th. So in order to do that, we're going to get 2 to the 2nd times 2 to the 2nd times 2 to the 2nd, still with me, times 2 to the 2nd times 2 to the 2nd 5 times. Now, in the last video, you just saw the 2 to the 2nd times 2 to the 2nd times 2 to the 2nd. We're all going to add these exponents. So if we add our exponents, we ended up getting, I'll write it down here actually, 2 to the 2 plus 2 plus 2 plus 2 plus 2. So 2 plus 2 plus 2 plus 2 plus 2 is then equal to 2 tenths. So for the next problem, we have 3 to the 4th all squared. So in order to do that one, we take 3 to the 4 times multiplying 3 to the 4 times 2, which is then equal to 3 to the 8th. For this problem, we have w to the 5th all to the 4th. So what we do with that is we take w times 5 times 4. So w to the 5 times 4, which is then equal to w to the 20th. Our next problem we're going to do is 4 to the 3rd all to the 5th. So we take 4, and we take 3 times 5. So we end up with an answer of 4 to the 15th. Our next one we're going to do is y to the 2nd all to the 4th. So now we have y 2 times 4, which is then equal to y to the 8th. As we go about our last problem, we have -4 parentheses to the third, all squared. Now, those parentheses are important because it brings that negative with it. So we have a -4 times a -4 times a -4. So the way we write this one is -4 to the 3 times 2. But we have to put our parentheses in there, or it's not the same problem. So -4 times 3 times 2, which is then equal to -4 to the 6th. Next, we're going to step it up. But don't let that worry you. I'll take you right through the problem. So now we have 2x to the third. Now this is a little bit different because I like to do what I call distributing the exponent. So you take the 3 to the 2 and the 3 to the x. So as we distribute that exponent, remember that there's a little 1 here because it's 2 to the 1 is equal to 2, and 2 is equal to 2 to the 1. We also have x by itself, so it's x to the 1 is equal to x, and x is equal to x to the 1. So we take 2, we have 1 times, because we multiply our exponents, because the exponent's on the outside. Now we multiply all of that by x to the 1 times 3. So our answer is going to look like 2 to the third times x to the third. Our next problem follows the same strategy. So we distribute that 2 to all parts inside the parentheses. And all of these have those exponents of 1. So since we have those, we have 3 to the 1 times 2 times x to the 1 times 2 times y to the 1 times 2. So then that's going to equal 3 to the second times x to the second times y to the second. Next, we're going to do 5y quantity to the fourth. So we have 5, so there's a little 1 here, so 5 to the 1 times 4 times y, which has that little 1 there, to the 1 times 4, which then equals 5 to the fourth times y to the fourth. Next, we have AB to the fifth. So for this, we have A and B both have that little 1. So it's A to the 1 times 5 times B, which has that little 1. So we take B to the 1 times 5. 5. So our answer is A to the fifth times B to the fifth. Now this one is for all the money. Put it all together. So we have a 1/2 m in all squared. So 1/2, you may think it looks scary. Treat it like a regular number. So we just put our parentheses, 1/2 squared times m squared times n squared. And voila. Now, one thing we didn't do in any of these videos, but you will be asked to do later on, is evaluate. So remember, evaluate means to find an answer. An example of that would be like 3 all, so squared, 3 squared to the third. So then you would take 3, 2 times 3 is 6, and now you would need to find what 3 to the 6th is actually equal to. So we find that 3 to the 6th is actually equal to 729. So the last thing I want you to do is I want you to get up out of your seat, go over to the door by the calculators, and rip off an extra problem.